them. Yeah, then you know them because I do not say, Saidi or Pisiza. I say Inocybe or Pizziza. So that might be, if that is not a problem. You can always ask your questions in the chat, as already said. And I have the chat window here open, so I can directly tell you the answers of your questions. Before we start, what the topic of this this evening or this morning is Coprophilous petisalis. That means Coprophilous cup fungi, but the presentation has a lot more to as a content, also Kernpilze, Paraenomacetes, and also other groups. The presentation deals only with cup fungi, and the PDF you can get from me also deals with Paraenomacetes and all the other groups. So there is a lot more of it to learn and to check out. We only talk about cup fungi, which are also known as Discomycetes. So the three groups we are talking about are Pizzitomycetes, Leotiomycetes, and Orbiliomycetes. These three groups. And there are a lot of species in these three groups. I think about 300, 400 different species. And I've seen a lot of them, and I will show you some of them, especially those with larger or more interesting features. So that will be a very nice presentation, I hope. Let's start with the first genus. It's Ascobolus, which is, I think, well known because of larger fruit bodies, because of interesting spores, interesting asci, interesting features. And there are a lot of species which are easily identified by Van Brummelen 1967, I think. I think the date is right. So what you see here are just four pictures of examples of this group, Ascobolus, which is typical with fruit bodies which are in younger states hyaline, whitish, and they go like purplish, get purplish with age during the when the spores are mature, because the spores are purplish violets in the older stages. And you can also see some information here on this page. This information is given in German, but you can ask if there is something, if there are some questions. With Google Lens, I think it's not a problem to translate just this few words. The size of the fruit bodies, that is about 1 millimeter, sometimes less than 1 millimeter, like Ascobolus furfuraceus, which is shown on bottom right. This is about 2 millimeters, and 2 or 3 millimeters is very large for this genus. But it is also large for in comparison to other genera, because there are lots smaller fungi out there. What I mean with Dung factor is if you have 100 species in Ascobolus, there are 85 species growing on Coprophilous habits. So Coprophilous means excrements of various animals. The rest of the genus grows on carfoil and on soil and other substrates, like on wood, which is very rare in this genus, but it's possible. Here you can see a photo of typical appearance of Ascobolus furfuraceus On the right side, you can see some immature fruit bodies without spores, and you can see some major fruit bodies on the outer right side, which have already some black dots on the surface. That means there are ripe major spores on these fruit bodies, and they are ready to shut up. So if you blow them, or if you touch them, all these astae will shut the spores out. On the left side, you can see some other species also co-occurring with the fruit bodies of Ascobolus, like Chilinenia and Telebolus, very small brownish dots you can see here on the left side, and also Sporamiella, very small blackish dots embedded into the substrate, so not easy to see there. So on a very small size, you can see many different fruit bodies of many different species. This is also possible. This is the largest fruit bodies of Ascobolus ruferatius are about 2 or 3 millimeters, just for information. And if you take them to the microscope, you can check the spores, how they look like. Which is also which is always very important, because when you try to identify the species with von Brummelen, the key will always ask for how the spores look like. Are they smooth? Are they watered? Are they with ridges, like here on this photo of Ascobolus roseo-purpurascens, or is there another ornamentation? And also the size of the spores is very important. And you have to check them in major states, because it's not possible to identify when they are immature. So when you look at this photo here, it's useless to check the immature fruit bodies microscopically, because here are the spores hyaline without any color. And the color is visible only in mature spores. The color is like purplish brown. You can see on the bottom of this photo, you can see some immature spores here. They don't have any color, and they don't have any ornamentation, so it's not possible to identify them. You can see some spores and astae of Ascobolus brassicae. The name comes from plant genus Brassica. Was heißt Kohl auf Englisch? Cabbage.
Cabbage.
Cabbage. It's a Brassica. It's cabbage. That means the first records of this species were found on cabbage, and but it's also very common on excrements of rats and mouses, and also some others. It's not very rare, but you have to look up for it. It's easy to identify microscopically, because this has globospores, which is very rare. It's very rare character in all of the Coprophilous fungi, but it's very typical for Ascobolus brassicae. It also has its own subgenus. It is called Spheridiobolus inside the genus Ascobolus. So we have two groups in Ascobolus. The one group has disc-like fruit bodies, and the other group has globose fruit bodies, which are sometimes called Glycetechia. Glycetechia means the globose fruit bodies are completely closed, and hymenial structures are closed into this fruit body. And the astae break through the fruit bodies and are ejecting over it. So you can see 1, 2, 3, 4 astae with very easy visible spores. You can see 8 spores in each astae, and they're ready to shut out. So it's not easy to take photos of it, because when you try to take photos, they are always shot up, so in the air, so they are very. I have 2 or 3 or 4 different species of this group with globose fruit bodies. The most common is Ascobolus immersus. You can see that on the left side. This is very common, and this also appears together with like Ascobolus furfuratius. They are very common on cow dung, for example. You can just collect cow dung, and you always have very common this species. There are also undescribed ones. I've seen one on Madeira, like Ascobolus madeirensis. Just a provisional name for it, and this is an undescribed species. So even in this genus, which is very well studied through the literature, through the times, this is there are some species still left to describe. This subgenus is called Dasybolus. So there are likely 3 subgenus in Ascobolus. The first one is Dasybolus, the second one is Sphaeridibolus with globose spores, and the third one is Ascobolus itself, which has disc-like fruit bodies, like Ascobolus furfuratius. All this text written here, it's the same what I've just explained. These are very small, like unlike disc-like fruit bodies. The globose fruit bodies are like just 200 micrometers broad or 400 micrometers, very small. So even smaller than the others. Okay, then there's a literature. I think you can. Literatur is German, and literature is just in English. You can put an E behind it. It's Van Brommelen 1967. You have to use for this genus. This is very important because we don't have recent literature about Ascobolus, but Van Brommelen is a very great work. There are some species described after Van Brommelen, but it's still very in use. This is Ascobolus madeirensis, which I've called Madeira Kotbecherling. That means just like Madeira Ascobolus, which is a species undescribed. You can see globose spores, which means that it is possible placed in Sphaeridibolus, in the subgenus Sphaeridibolus, maybe. This is a species which does not occur in Europe, and also not in America. It is from Africa. There are some species of Ascobolus just known from Africa, from the African continent, like Namibia or Congo. And they sometimes grow on special dung, like from giraffe or elephants, which is not easy to get in Europe. Even in zoos, you don't have these species because they only grow in natural habitats in Africa. They have very special spores. You can see some warty labyrinth-like ornamentation, and you can also see that the fruit bodies are globose. That means this is again the subgenus Dasybolus, which is very similar to Ascobolus immersus. But the structures, asci and spores, are way smaller than in immersus. You can check Mungai. He is very active with dung fungi in Africa. In Mungai et al. 2012, there are all these species from Africa, Ascobolus and Dacobolus species from Africa described. This is like how it looks like, Ascobolus degluptus. This is from the subgenus Dasybolus. You can see the asci, highly projected from the fruit body, and you can see the spores inside, which have very special features, like some ornamentation in the middle of the spore, which look like is some overlay. The overlay, the purplish overlay you can see here is also sometimes also called epispore, which is that's a term for it. So this is next genus, Ascodesmis. Ascodesmis nana, which I show here. It's Ascodesmis consists of, let's say, 10 species, and all these 10 species are very, very rare. There's no common species in Central Europe I know of. I have just seen 2 of them in about 15 years, so it's very, very rare. Obrist 1961 is the literature you can use for it, for all of these species. And sometimes you can also see them in other literature, but they are mostly not described because they are so small, and this is very hard to find them. So you can see some macros, and the size of these blue bodies is below 100 micrometers. So this is very, very small. You can see a hyphomycete on the left of this photo, which is some likely 80 micrometers high or so. That explains why they are not easily found. There's another one of the same genus. You can see Ascodesmis. Ascodesmis is very easy to identify due to the ornamentation of the globospores. So the spores are mostly globose, and they also mostly have a very special ornamentation, like nets-like ornamentation, which is very rare in asthma seeds like that. You can just see some brownish dots here. That these are the asci, the very, very small fruit bodies, which consist of only a few asci. So these are a bit larger, Chilemenia, and well known, I think, because if you see some cow dung or from horses or from deer or whatever, you can sometimes see some yellowish fruit bodies, and they mostly belong to the genus Chilemenia, which is very common and easy to identify. If you have a closer look, you can mostly see that the fruit bodies have some setae-like hairs on their edges. Chilemenia consists of about 67 species worldwide, which is a lot. The most common species in Central Europe is Chilemenia granulata, and I think also worldwide. Chilemenia granulata, there is an older name for Chilemenia granulata, which is Coprophilous. Coprophilous is the older name, but it's granulata means granulate, and that's because of the edge of the fruit bodies. They don't have hairs. Instead, they have some warty ornamentation, and that makes the name granulata. And that's also the reason why it was put into its own genus, because it doesn't have hairs in comparison to the other species of this genus. You can use Moravec from Czech Republic from 2005, which is a monograph of Chilemenia. So if you want to identify them, you have to use Moravec, because some of the species are not easy to identify. You have to take them to the microscope always, and it's not easy to identify them because they have sometimes some special ornamentation on their spores, which is very hard to see. It's, only visible in cotton glue. So when you put cotton glue into the preparation, you can sometimes see that there are some stripes, some longitudinal striations on the spore surface. And if you see them, it's good. But if you overlook them, you don't have any chances to identify them. That's a close-up of Chilemenia stercorea, where you can see the hairs. the large hairs are brownish on the edge of the food body, and there are additional hairs which are star-shaped. You can see them here in the middle. There is a star-shaped hair. This is very, very special, and this is very typical for Chlamydia staphylococcus. And when you observe them with the microscope, they look like this. You can see the long hairs here, long hairs which have some root-like basis, which is important for determination. And you can also see the stellate star-shaped hairs on the outside of the food bodies. The globose and the somewhat polygonal shaped cells are called excipolium. It's sometimes important for determination, but actually not really not in Chlamydia. On the left side, you see the ST and spores and parophysis and all the other stuff. Chlamydia, no, it's Coprophilous. Coprophilous is a genus which has some of 33 different species worldwide, and they are mostly hyaline to pale yellowish, sometimes brownish, but mostly these pale colors. And they always mostly have some protruding ST. And you can see the spores inside the ST. Sometimes there are 8, sometimes there are 16, sometimes there are even 128. So multi-spored ST, which is quite typical for Coprophilous. You always have to count them if there are 64 or 128 or 256. So it's some time to count them. There is a name just like the most common species in Central Europe, like Coprophilous sextillium spores, which means 16 spores per ascus. They always grow on dung. What I call dung factor is that all of these 33 species grow on dung. When you try to identify them, use Kimbrough et al. 1972. Which is the best key for Coprophilous. There is also a newer key from I think, what was it? I think there is a newer key. If you are interested, I can show you later. So here are the ST with the 16 spores. You can count them. There are really 16 spores: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 spores per ascus, which is quite typical, and this is very easy to identify, like Coprophilous sextillium spores with these active. That is Coprophilous carnuliformis, typical appearance, very pale fruit bodies, and protruding ST with hyaline spores. Always hyaline. Also, fully mature spores are hyaline and mostly thick-walled. So the wall is somewhat darker, and it looks like as if there is a double wall. That means thick-walled in ascomycete. Yeah. No hairs in Coprophilous. There are no protruding setae hairs or whatever. So no hairs, but only a lot of ST which are very well visible, and paraphysis, of course. Sometimes paraphysis are uncinate, which means they are bent at the pieces, which is a very important character for determination. Yeah. Iodophannus. Iodophannus is just a small genus of just a few species. I think there are 15 worldwide. Here in Europe, I just know 2 or 3 of them. For North America, I'm not sure. I think most of them are described from the tropics or from Asia. Iodophannus means it's actually a genus which you can check microscopic characters with iodine solutions like Melzer or Lugol's. which turns heminial structures bluish. That means yodel. That's a reaction to iodine solutions, which is very important to check, because you cannot. It's not easy to identify the genus to differ it from Coprophilous, because Coprophilous sometimes looks very similar. And Coprophilous does not have any reaction to iodine solutions, but Iodophorus has. So you can see it on the right photo here, on the micro photo. The asci turn blue in iodine solutions. That works with every species in Iodophorus. And if you have a closer look to the spores, you can also see that there is a very minute ornamentation. That's not easy to see. You have to use cotton blue to see that there is some dots on there are some dots on the surface of the spores. That is also a character which does not occur, which does not occur in Coprophilous. So it's maybe not so hard to identify. If you want to check out how to identify this species, you can use fungi Finiculi italici from Dovery. Dovery is a very active mycologist for dung fungi in Europe, and he has written a lot of articles and a lot of books about fungi and dung. This is Lasibolus. Different species of Lasibolus. Some are violine, some are yellowish, some are reddish, and they mostly or always have some sort of hair-like structures on their sides. They look like some very stiff pointed setae. And that means that also means the name Macrotrichus, which is just like very large hairs or setae on the fruit bodies. This is very common. The genus is very common, like just like Ascobolus and Sacrobolus, and it is very easy to identify with a lens. There are 11 species worldwide, not so much, and the most common is likely Lasibolus ciliatus, which is shown here in the bottom left. They always grow on dung. There's no species growing on herbs or wood or whatever. I always find them on different dung. And it's also Dovery, which you can use for determination. I can show you one special species in this genus, which is called Lasibolus monascus. Usually you have a lot of asci per fruit body. So you can see here there are maybe 30, 40 asci per fruit body, or even more, a lot more. And there is one species which is called monascus, which is a Lasibolus, which consists of only one ascus inside the fruit body. You can see the ascus shape just inside the fruit body, and this ascus has about 500 spores, or even thousands. I'm not sure. I didn't count them because I'm not so crazy. It's just typical for monascus, and this is very easy to identify. And it's very strange and a very special species of Lasibolus. So here we are with Orvielia. Orvielia is a well-known genus which occurs on xeric substrates, like on hanging attached twigs of trees, bark, mostly without bark, and they are distributed worldwide. The genus has about 470 different species worldwide, and in Europe there are 230. You can use Barral and Marsan for identification of Orvielia. There are very large books which are also available online. via the Luxembourg Society, I think, Luxembourg Society, Botanical Society. I'm not sure which it is, what it is called. I think Sigrid can give you the link later or whatever. I can give you the link. There are just a few species growing on dung. I think there are only 2 of them, which have been recorded, or 3 which have been recorded from dung. And Obelia ellipsospora is just one of them. Obelia mostly has somewhat watery look, like watery fruit bodies, and mostly whitish or pale yellowish, sometimes reddish. And they are mostly very small, like some below 1 millimeter, mostly even a half millimeter, or maybe less than that. On the right side, you can see an anamorph spore. So all of these Obelia species have anamorphs, and sometimes it's necessary to find this anamorph. Sometimes the anamorph grows just at the sides of the Obelia fruit bodies, and you have to check the spores. If you don't do that, some Obelias will not. You will not get the names of them because it's impossible to identify them. This is the genus Petitza, Saira. Petitza has a lot of species. The concept of Petitza is has been renewed by Van Hoven et al. And they have created a lot of new genera inside Petitza. So Petitza is not Petitza as we know it. There are a lot of new genera to learn. And I think in the original sense, there are 120 different species inside this genus. So it's very complex and it's not well understood. The most common species on dung, however, is Petitza femiti, which is just shown on the right side in several different major stadiums. So dung factor means 8%. There are just a few species growing on dung. Most of them grow on soil, on wood, on herbs, on whatever, but dung is not the main substrate here. You can use doggery, however, for the few species occurring in dung. You can use the keys given in doggery. So actually, Petitza, if you want to know how to identify Petitza, most of them have really large fruit bodies. That means centimeters or 2 centimeters, 20 millimeters, 30 millimeters. So very large and well visible. And they mostly don't have any hair-like structures on the edges. So the edges are very smooth or granulate like in Femiti, but they don't have hairs. And if you check them microscopically, it's easy to observe the asci in iodine solutions. They will get a bluish color, either entirely or just the ascus tips. And Petitza is an own presentation I have in hand, but it's very complex genus, and it's not easy to tell you every detail in just a few minutes. So maybe we will have another presentation about Petitza sometimes. Okay, there is the Pseudombrophina. Pseudombrophina is a small genus of only 37 species worldwide, which has Pseudombrophila theoloica as its most common species, which is shown on bottom left. These species don't have hairs on the edges. Instead, you have somewhat warty or somewhat what do you call it, granulate edges. Sometimes purplish colors, which is also typical for Pseudombrophila. They don't only occur on dung; they can sometimes also occur on soil but sometimes you cannot see if there is a dung of animals, and you just have to check what's below the food bodies. It's not easy to see that. You can just see the soil and some sandy substrates or whatever, but you cannot see the excrements. It's sometimes very small or whatever. You can use Van Brummelen. There is a monograph he has written in 1995, Van Brummelen again, who has also monographed Ascobolus and Saccobolus. And in 1995, he has monographed Pseudomorphilia. And you can use the key there. It's not easy to identify the species, but sometimes you have success. This is Saccobolus. Saccobolus is just like Ascobolus, which means the fruit bodies have some dot-like surfaces. The surface will get dark. Will get some dark dots all over because of spore mature. When the spores are mature, they will get a dark color, and that causes the fruit bodies to have this blackish dots all over. This is just like the same as you have seen in Ascobolus, the same character. So the difference between Ascobolus and Saccobolus is just that Saccobolus has the spores clustered together. So all 8 spores are clustered into a so-called cluster, and the arrangement of the spores inside this cluster makes some very important features for determination. I will show that later. Saccobolus has about 33 species, and I think a lot of undescribed ones, because Saccobolus is way smaller than Ascobolus, which means you have fruit bodies about 200 micrometers or 400 micrometers diameter. So that's very, very small. They are either whitish, hyaline, or purplish, or they are yellowish. These are the main colors inside this genus. There are no other colors actually. So there's the Depauperatus as the main or the most common species, and also some Depauperatus is one of the smallest species, which means I have seen the Depauperatus collections about 80 micrometers diameter, which is very, very small and bearing just a few asti per fruit body. The fruit bodies are just 100 micrometers to 1 millimeter in diameter. All of these fruit bodies or all of these species grow on dung. There is no other substrate actually, and you can use Van Brummelen 1967, which means that's a monograph of Van Brummelen for Ascobolus and Saccobolus. Both genera are included in this book. This is just a photo of Saccobolus verrucispores, which I have added to the presentation. I have an own presentation for Saccobolus, which also has 80 pages or 85 pages. This is also very complex genus, which I have worked in detail. And it's you can read the description. Here's just a few words which are characteristic for this species, Saccobolus verrucisporus. Is the ornamentation on the spore surface of many of these dung fungi structural? Does it reinforce the structural integrity of the spores? And if so, does it do this for survival of the spore inside the digestive system of the animal or outside in the environmental growth? I think the surface structure and the thickness of the spore wall allows the spores to go through the digestive system of the animal. But sometimes I have also I have also a lot of observations of small animals like springtails or mites which can carry the spores all over. So this might also be a factor for some of the species. Yeah, the Saccobolus presentation is also available. So the Saccobolus says the Saccobolus presentation is full of this photos like this. These are the spores of Saccobolus verrucisporus. The very special spores. You can see cluster, which means all 8 spores are just glued together, and even if they are ejected from the ST, they are still in this cluster, which is very, very typical for Saccobolus. That does not occur in Ascobolus, and not in any other genera I'm aware of. Also, the surface structure, which is just the epispore. This is very typical for a Saccobolus species. In this case, very typical for verrucisporus, which just means verrucisporus, which means warty, granulose surface of the spores. Yeah. Yeah, I have just added some. Sorry, that's just it's just my computer, which is too slow for showing all these photos. Wait for it. No, there we are. Just I think there are too many photos for my computer to show, so it takes some time. These are the Saccobolus species I know of, and these are all of these photos show different species from all over the world. So there are somewhat arranged with their colors, like the hyaline ones on top, and some purplish ones, and on the below there are a lot of yellowish ones, and also some with very strange and very rare spore cluster arrangement, like the ones you can see below on the bottom right. Here are the clusters of all these different species. You can see them. Most of the spores are photographed when they have been released from the ST, and they mostly glued together, but not all. There are some species where the spores are loosening from this cluster, like in Saccoboloides, which means there is no cluster yet. There's just loose spores. Yeah. So the next genus, Coprophilous. Coprophilous has about 23 species worldwide. There's also a key for it, which is from Cousin et al. 2015, where you can easily identify all of the species, but you have to check the spores, you have to check the number of spores per ascus, which means like in Coprophilous pelletieri, there are about 32 spores per ascus, which is very typical for this species. Some of the species grow on wood. They are not all. They are not only Coprophilous. Typical for Coprophilous is the reaction with iodine solutions. So we have Pizzica, we have Iodophanos, and we have Coprophilous, which genera easily identified by the reaction to iodine solutions. That also happens with Ascobolus and Saccobolus, but Ascobolus and Saccobolus are very easily identified, even by without a microscope. But Coprophilous and Iodophanos and Pizzica are not always easy to identify. So you can just add iodine solutions, and you can see the very bright and very beautiful colors which are caused by the reaction of iodine solutions. Sometimes you have to check, actually you have always to check the spores in every genus, but here you have to check the appendages. Appendage means there are somewhat like knob-like structures on the sides of the spores, which belong to the spore itself and which are easily recognized in cotton glue. As you see here, cotton glue stains these structures, and if you see them, it's a lot easier to identify the species, like Ticotius skjoldi. These names mostly come from northern observations in northern collections. So skjoldi is just a name for this species. This is observed in cotton glue, and cotton glue we already had this cotton glue in other genera. So anytime when you have spores where the surface structures are not well visible in water, you can check them in cotton glue. That makes lots of things easier. So this is Trichobolus. Trichobolus means that is globose fruit bodies with some hairs. That means Trichobolus. And typical for Trichobolus is that the hairs are everywhere on the fruit body, not only on the edges, but actually they don't have an edge because the fruit bodies are globose, which are so-called cleistotecia. We already had this term in Ascobolus. If you remember, we had this in Darcybolus, the subgenus Darcybolus. In Trichobolus, you sometimes have some very large ST. There are only 6 species, and the most common is very probably Trichobolus zucalii. This is the most common. And if you prepare dung for observing fungi, mostly you have these species at the beginning of the observations. So if you collect droppings from animals, you can observe them after about 10 days or 8 days. So very fast. And that means that the dung has to be very fresh to observe some of these. And Trichobolus zucalii is a very common species. Are some of these fungi specific to the host animal, like horseworm? Yes, they are. Sometimes they are. I'm aware of a lot of species which are very specific. So here you can use Doveri, which where is the key for all of these species. Only 6 species, which is not hard to identify actually. And when you see some globose fruit bodies with hyaline spores and covered by setae like this, you can call them Trichobolus, also microscopically. This is very easy. But I think the most similar genus is Larsibolus. Larsibolus and Trichobolus are sometimes not easy to identify. Microscopically, I'm not sure. I don't have a microscopic photo of it, but Trichobolus zucalii just consists of only 1 ascus per fruit body. That means the ascus is visible here like this yellowish top of it, of the fruit body, which is just the ascus tip. This is very strange. There is a large ascus inside this fruit body, and the ascus contains about 2,000 spores. 2,000 spores per ascus. Sometimes 2001, and sometimes 1900. I've always count them. But don't have to do anything else. Okay. Ascozonus. Ascozonus is a very small genus of hyaline species. Like you see them, 2 of them here on this page, like Ascozonus monascus or Ascozonus wolofopensis. The Ascozonus monascus means just with 1 ascus. So actually, that means that Ascosaurus monascus refers to the fruit body, which has only one ascus and a few paraphytes around it. I have seen Ascosaurus monascus also growing clustered together, so that it looks like a large fruit body with a lot of asci. Actually, these are only just fruit bodies clustered together. So there are about 60, 70, 80 fruit bodies clustered together to a somewhat like, you might call it pseudo fruit body, whatever. This might be a stage of evolution here to more complex fruit bodies with a lot more asci per fruit body. Also, the ascus and the spores inside this asci look very, very strange. They have a very strange placements inside this asci. Ascosaurus volupensis is the most common one, which is shown here on the bottom right. And mostly they are very, very small. And I have also observed that they rather fastly drying. When you put them out of the boxes, they are drying and they collapse very fast. It's not easy to take photos of them. You can also use Doppleri for identification, which is very easy because you have to check the number of spores per ascus, and then it's some of the species have larger fruit bodies and some have very small fruit bodies, and that's it for identification. There is even smaller. There is a genus which is called Pseudascosaurus, which is not a real Ascosaurus, which looks like Ascosaurus, but it is not Ascosaurus. It's different. It just has some very small asci and very small ellipsoid spores. And actually, this genus consists of only one species, which is called Pseudascosaurus racemosporus. You can use Van Brummelen 1985 for it, where this genus and also the species is very well described. Yeah, it's you can see the fruit body here. The fruit body is about 50 to 100 micrometers in diameter, so it's even smaller than everything we have seen before. There are just a few very small fruit bodies, asci, and you can even see the spores in this asci here. So, okay, I've tried to make everything visible, everything. There's another species in this genus, which I called Pseudascosaurus. What did I call it? I'm not sure. I don't see.
Madarensis.
Madarensis. Yeah, I have a lot of windows here. Open a chat window and everything. So Pseudascosaurus madarensis, because I found it in Dong from Madeira. And I think some of these fruit bodies confluent, so they growing to a larger fruit body mass with a lot of spores and a lot of asci. And actually, if you have a closer look to some of these fruit bodies, you can see that there are large extipular cells on the bottom of the fruit body. And out of this extipular cells, there are growing out some asci. That's all. So this species doesn't even have some paraphytes. It's just it's just a bunch of asci growing out of extipular cells, which is very typical actually for Pseudascosaurus, which is also visible in Pseudascosaurus racemosporus. And that's the reason why I put this collection into the genus Pseudascosaurus. This is very possibly an undescribed species. And just an example that there are a lot of undescribed, unknown species out there. waiting for this, waiting for description. So if you don't have anything to do, just look for undescribed species. It's very easy. Like Hyolus typha or Hyolus typha is a genus of small hyaline leotiomycetes. That means there are very small disc-like fruit bodies, which mostly grow on coniferous wood or deciduous wood, and they are very common everywhere, but actually not known from dung. So this is probably the first record of a species of this genus growing on dung. This is very, very rare. The genus has about 38 species, which all grow on wood, on plant debris, but actually not on dung. So this is actually this is new to science. You can use Reitvier 2004 for all of these smaller Hyolus typhaceae, which is the family of Hyolus typha. Reitvier has a key for all of these small disc-like fungi with hairs on their edges. You can see, you can also see hairs here in the fruit body edge. This is well known. This is Unguiculella titurii. You can see a perennomycete here. This is a Schizotetium or Schizotetium. Sagt man das Schizotetium? So wie Schizophyllum. No, it's a Schizotetium. This is a perennomycete genus, and sometimes it is parasiticized by a leotiomycete called Unguiculella titurii. You can easily see them here growing beside or sometimes on top of the Schizotetium fruit bodies, which is very, very strange and very rare case. But the Unguiculella titurii seems to be restricted to some very special regions. We have some regions here in the Black Forest where we can collect cow dung every year, and always it's observed everywhere, every time from the same place. So this might be very specific to a special region. I don't know what the reason for that is. It grows on cow dung and directly on top or on the sides of this Schizotetium. Microscopically, it's typical for this very small asci and small ellipsoid spores. So microscopically, it's not so special actually. It's very boring in structures. Unguiculella has a lot of species which mostly don't occur on dung. They occur on woods and grasses and ferns and mosses or whatever, but usually not on dung. This is very, very special. It's actually this is the only species which is known from dung. Very small, likely 500 micrometers broad, and with this appearance, it's very typical. So you cannot misidentify it actually. Putin and Spooner has described it in 2005, so it's very well described and very well known actually. I have actually found a different species of Unguiculella, also growing on dung, but not related to any other fungi, so not growing on perennomycetes or whatever. This species is also undescribed, I think, Unguiculella funiculata, which is typical for its glassy structures inside its hairs. So these are the hairs, and the hairs are they have some glassy refractive structure on their upper half of it. So it's very typical for Unguiculella. but there is no species on Dong described like this. This is very, very special. Oh, actually, Urziolella. So I'm sorry, it's not Unguiculella, it's Urziolella. This is a name mistake here. Urziolella is the name. Actually, the Urziolella carstiana is the most common species which grow on ferns. If you check ferns for very small species with these hairs, you have Urziolella carstiana, which is maybe in a species complex of at least 4 species. You can use right here for it, but you will not have success to identify Urziolella funicola because this species actually doesn't exist, but it's just undescribed. So it's Urziolella, not Unguiculella. Sorry for this name. So here is the last genus, Telebolus. Telebolus belongs to Leotomycetes, and it belongs to its own order, like Telebolales. It is very special. Telebolus is easy to identify because you have just to count the spores, which is sometimes not easy. The 8 spores per ascus is easy, like Telebolus microspores with its typical yellowish chlorophylls heads. But if there are 32 or 64 spores, it's not so easy. Sometimes you have to count several ST, and just to get sure if there are the right numbers of the spores per ascus. So here are 32 species with 32 spores per ascus, and on the next page. Now, there are some more, likely 64 spores per ascus. There are species like Telebolus polyspores with about 128 to 256 spores per ascus. There is Dubius lagopi with also a lot of spores per ascus. And there is Telebolus stercoreus with about which has only 1 ascus with about 1,000 to 2,000 spores per ascus, which is just like the same as we have seen it in Trichobolus tucalii, as you remember, which has the yellowish head. Here it is somewhat pale yearly, and in Trichobolus tucalii you also have the setae, and here you don't have any setae, which is the character for Telebolus stercoreus. And if you put them into a preparation, you just have only 1 ascus with a mass of spores. And if this ascus breaks, you have spores everywhere, so that you might actually you might think that this is not even an asthma seed. It's maybe it's an hyphoma seed or whatever. But the large ascus is mostly well visible in the preparation still. Here it is. You can see it's just somewhat like excipular cells around this large ascus. That's all for Telebolus stercoreus. So that was my presentation. I hope you enjoyed it. And if you have any questions, you can just write them in the chat, I think, or I think we can go over to Sigrid.
Yeah, thank you so much for presenting these. And just to anybody who's never photographed the dung fungus, it's incredibly hard to capture them. And the photography in the microscopy is just stunning. So, if you have any questions about how Björn comes up with these incredible images, this is also a good time to ask him. So I don't think we have any outstanding questions in the chat, but I know that several of you will have questions. So
I think Ethan Crenson had a question.
Oh, no,
that was
Björn answered
okay.
it. Björn answered it, yeah.
Okay.
So yeah,
But I do sort of want to comment that the photography is so detailed. It seems like you can almost see features that you would examine microscopically in like a transitional state between microscopic and macroscopic. And is that something that is necessary, you think, for identifying a lot of dung fungi or no? Like very detailed macro photos, showing details that you wouldn't otherwise see, say, with a low powered dissecting scope.
I think it's just in advance. Yeah, it's just it's just positive for identification. Yeah, definitely. It helps you a lot with easier identification.
Beautiful photos, really stunning.
So especially in basidium seeds, when you have to look for cystidia, child cystidia, or cowled cystidia on the sides of inocybe, it's very easy to take photos of them through the microscope, so that you can see them macroscopically, to check where they are, just on top of the stem or going to the middle of the stem or whatever. So that makes identification a lot easier. Also in coprinoids, Coprinus species, it's sometimes also necessary to, or often necessary to check the child cystidia and parent cystidia, which is a lot easier to check them macroscopically and to take photos of them macroscopically. That makes the identification process a lot faster, and also in ascomer seeds especially.
So Ross asked a question, and I know you answered it in your presentation, but she asked about specialization. Are there dung fungi that will just literally grow on anything? And are there dung fungi who are extremely picky and will only grow on the dung of one specific animal? What's the sort of typical spread of specialization?
I think you can put the excrements of the animals into some groups, like rabbit-like, like horse-likes, like cow-likes, like deer-likes. But I'm not aware of a species which grows on only one animal dung. Mostly they grow on different ones.
Great. Thank you. I think Elan had a question. Elan, do you want to ask your question?
There are some questions in the chat as well.
Oh, yes. So, yeah. So, Elan, do you want to read out your question?
What are you?
Sure.
Yeah.
I was asking, what are you photographing these pictures through? Is it a stereoscope or using a 10x objective on a compound scope? And what's the average number of photos you use to stack? And what software, if any, do you use for post-processing them?
Yeah, Sigrid, if you allow, I can just change the presentation to show that. I'm trying to wait. I have first to check out how that works. I also have a presentation. I have a presentation for only for this macroscopically photography, and
that should be possible. Yeah, if you just stop. Yeah, there you go.
Do you see that?
Yes.
So in this presentation, I have explained how to do that, how to take photos like this on very tiny species. And the way I do this is just like this is just like a do-it-yourself thing. So I have just this microscope. I have some objectives. You can put objectives up to 16 magnification, and you will have magnification of 160 at highest, because magnifications higher than that, you will not have the light for magnifications like this. There is the lights here, and I'm just enlightening the thing I'm taking photos of, and I'm just taking the photos through the eyepieces with a Canon camera. This is very easy to do here like this. So the result of it is just like a photo, like you can see here. Yeah, this is the result of it. Just if you are, you have to try it a bit. I think you have to try a lot, and it's not easy to do it with the first try. So surely the first tries will not be that good, because it's not easy to learn that. Yeah, it's, I think this is an own presentation. This is an own presentation and an own thing to explain all that, because it's a lot of things you would learn from this year, but it's you don't have the time for it. I think it's just a lot of stuff here. I have a lot of tricks and tips, and the best thing to learn that is to come here and to learn it. But it's not easy for me to explain all of it, especially not in English. I would explain it better in German, but I try. Are there one or more regions of the world which are especially rich in dung fungi diversity as compared to the rest of the world? I think in the tropics, the diversity of the species is not so rich, because in the tropics you have a lot of rain, and due to the rain, when I was in Panama, I tried to find Coprophilous fungi on dung, but it was not easy. I haven't seen a lot, actually. So maybe in the temperate regions you will find a higher diversity, maybe. Are your fiber optic illuminators emitting heat? No, they don't. And does this affect you? No, not really. But if I put the collections out of the boxes, they dry. That's for sure. So if you want to take photos of the collections, you have to be fast, because you have to spray them with water first before they start to dry. So it's not easy to do this, because you don't have a lot of time. And in Ascobolus, for example, you will have even lesser time, because of the ascus, because of the spore dispersal. So if the asci releases spores, they are not visible on the photos, of course. So it's just you have just a minute to take the photos. It's not easy. Is it available? Is this photography slide deck available to view? Thank you for the explanations. I'm not sure if I have shown this one in our group. I have hundreds of these presentations, hundreds, with about 3,000 pages. So you have to visit our courses. You will get them for sure, like secretness. Do you plan on offering any workshops courses in North America in the future? Wer hat das wohl gefragt? Der Danny hat das gefragt. Denke ich doch. Mixumop müsste eigentlich Danny sein, oder? If they are well paid, we will think about it.
Okay, we would love to have you over here, and we should definitely talk about next year. I know you're not traveling this year, but I think it would be awesome to get you over here next year.
Yeah, that will be nice. I think if you can start a workshop about. I think there is a lot of stuff we could do. A lot of not only the determination, identification of fungi, but also all the techniques and all the tips and tricks and whatever. It's I'm not able to show them in a week or a year or whatever. There are a lot of things to explain, and to show or whatever. Yeah,
Do
I'd
it.
like to propose that we invite Björn back for his photographing this. Okay.
Yes. Let's do
Yeah.
it.
What is the one of the species? What is one of the species or genera you most hope to find that you are not yet seen? I've seen every fungi. No, not every. Actually, I've seen over 4,000 different species. But I think there are a lot of species I want to find, like Philipsia. Philipsia, yeah. Like Galliella. Like Microstroma flocosum. And thousands of other species. So there's a lot of to do. If you work with fungi, you will never ever have every fungi, because there are a lot of, and you will work on them until you die. So it's a lot of things to do, always.
Right. Ilan, you raised your hand.
Yeah, question. What method or tips or tricks do you use to actually cultivate the dung to prevent mold and other types of things growing that you may not want to have grow?
Yeah, sometimes you cannot avoid growing other species like mold on the dung cultures, and you cannot avoid mites. That's mites is not easy to avoid, because sometimes they eat everything. When you have mites, they eat all this like fungi, everything. I think it's just luck. I collect them and put them in a wet box with some papers and some tissues, and I wait for the species to occur. And sometimes it works very, very well. And but I have some cases where it doesn't work. It's just like that. Sometimes I observe them for about half a year, so 6 months of observation of a culture. Because you sometimes have species like Parainomycetes, which occur just about 3 or 4 months after putting the dung into the boxes.
Yep. All right. Any more questions? Okay. I guess we will call it a day, and you all can go off to lunch or breakfast or dinner or wherever you're coming from. Björn, that was amazing. Thank you so much for taking us through what is just a fraction of all these, there's many, many more fascinating species here. This is just the tip of a large iceberg. Thank you so much for taking us through all of it. It was just stunning.
There's one left. There's one question left. If you had stronger external oblique light source, would you use higher magnification objectives than 16? I've tried with 20, but I think for identification, 16 is way enough, I think.
Great, thank you.
I mostly use 4, 10, 4, 6.3, 10, and 16 magnification for all the macroscopic photographs.
Right, and 16 is not easy to find.
I have 16 plan apo from lights, which is very special. I think I always say that this is, I think, the only one which has been produced. So I'm not sure. It's not easy to get them.
All right. Well, lots and lots of compliments in the chat. Make sure you read them. And yeah, thank you so much today. And, hopefully see you in person next year.
Yeah, sure.
Mhm.
We will see us. Always a
Alright.
pleasure.
All right. Thank you, everybody. And thank you, Björn.
Bye.
Thank you.
Thank you.
Okay. Thank you. All right. Bye, everybody.
Bye.